All right, welcome back, guys. Today is going to be part 2 of what we started yesterday. So we're still going to be talking about some points, lines, and planes, except today we're going to start introducing some postulates and theorems. Now, I don't want you to get too intimidated by those words. We are going to talk about what they mean, but it's not as serious as it maybe sounds. So we're going to define these two words first, right? Theorem and postulate. So the first thing that you need to know, a theorem is a statement. A theorem is a statement that can be proven true. All right. So you can maybe think of the Pythagorean theorem, right? That's a theorem you guys probably all know. There's actually a proof for that shows that a squared plus b squared equals c squared is always true. So that is a theorem. We know it's true. We can prove it. All right. So if something's called a theorem, you can look it up. There's a proof for it somewhere. All right. A postulate is a little bit different. A postulate is a statement that is accepted as true. All right. It's another word for a postulate is an axiom. That doesn't mean anything to you guys, but so a postulate is just accepted as true. It doesn't necessarily need a proof. And the reason postulates are necessary is because in order to prove something is true, you have to have some things that you already know are true. And so if there weren't any postulates, that would mean we don't know anything is true, and therefore we can't prove anything else is true, right? It's kind of a philosophical nightmare. So there are just some common sense statements that we just accept, and we say, yes, this is true, even though we can't necessarily prove it, all right? So we're going to talk about some of those today. So the first three that we're going to talk about only deal with points and lines. So we're not going to introduce planes yet. All right. So the first postulate we're going to talk about is it's called the 2-point postulate. The names aren't, it's not really necessary for you guys to know the names, okay? But it's just necessary to kind of have a general idea about these concepts. So the first one says, through any 2 points there exists exactly one line. And maybe this isn't immediately like, oh yeah, that's true. But if you think about it a little bit, all right, this has to be true. So think about if you have 2 points, okay? We know, or we're saying, all right, that there's a line that goes in between those 2 points, all right? There we go. That is true, okay? No matter where your 2 points are, you start at one point, you draw a line, because remember, lines go on forever, so it doesn't matter how far away they are. Eventually, it'll reach that other point and it'll connect them, right? So there has to be a line that goes through 2 points. Now, it says exactly one line. And the reason that this is true is because lines are always straight, right? So think about another line, right? In order for there to be something else that goes through those 2 points, it has to curve, right? And this is not a line, so that doesn't count. So there's no other way for me to connect those 2 points straight, right? Without being the same line, right? Actually, let's do this. Right? If I go to that point, all of a sudden I'm right over top of the same line that I was. Now, obviously, I'm not drawing straight, but you get the point, right? So there's only exactly one line through any 2 points. That's important to know. The next one, a line contains at least 2 points. This one hopefully is like common sense, yes, right? That's why it's a postulate. Don't necessarily have to prove this. Let's think about this for a second. Why is this true? All right, let's say we have 1 point. All right. Can that be a line? No. Okay, it has no dimension, right? Remember, a point has no dimension. A line has 1 dimension. So right now, it's not this isn't a line, it's just a point. In order to make a line, you have to have that second point. That second point is going to give us, right, our length. So this must be true. The line intersection theorem. If 2 lines intersect, then they intersect at exactly 1 point. This is another one, maybe not as obvious as 2, but if you think about it a little bit, yeah, this has to be true. And this is a theorem, right? This can actually be proved. We're not going to do that today, but you can look it up if you're interested. So let's say we have 2 lines, all right, and they intersect. We know they intersect at exactly 1 point, right? This point right here. Now, how do we know it's only 1? Okay, again, lines are straight, right? So in order for lines to intersect at more than 1 point, like let's say we have our line here. If we have another line, if we want it to intersect at more than 1 point, it has to do what, right? It has to curve. So this curve intersects that line at more than 1 point, but again, this doesn't count. It's not a line. So there's no possible way for you to draw 2 perfectly straight lines and have them intersect more than once. So these are three postulates and theorems to do with points and lines. So now we're going to talk about some that have to do with planes, all right? So this one says, if 2 points lie in a plane, then the line containing them lies in the plane, okay? So what is this saying, all right? Well, let's draw a plane. Okay, and let's say there are 2 points in that plane. So let's draw 2 points. Those 2 points are in the plane. Then the line containing them also lies in the plane. Why does this make sense? Well, the points are what make up the line, right? If the points are in the plane and the points are in the line, then the line must be in the plane, all right? It's not possible for that line to leave the plane because, again, the line is only 1-dimensional. It can only go in one direction, whereas the plane is 2-dimensional. So the plane is kind of going all around the line. The line can't go up, right? Because if it could, then that would mean one of those points weren't in the plane. So again, this line has to be in that plane, all right? That's one that makes sense to us, okay? Number 5, if 2 lines intersect, then exactly 1 plane contains both lines. So if we have 2 intersecting lines, let's draw 2 lines. I'm going to move this down a little bit. If we have two lines and they intersect, all right, what does that mean? So that means that those 2 lines essentially create a plane, right? You can kind of see how that's happening. If we can draw a plane, right, that's made up of those lines, all right? No matter where those lines are, okay, there's going to be a plane that's created by those 2 lines. That's really what a plane is. It's the intersection of 2 lines and then that creating a flat surface that goes on forever. Now, again, why is it exactly 1? Well, if there's another plane, all right, let's say there is a plane that goes like this, right? Well, it's not going to be through those lines. It could maybe be through one of those lines, But in order for it to be through both lines, since the two lines are going in different directions, that's creating that two-dimensional space, right? It would have to be the exact same plane that we already have. So this one maybe is not as intuitive as the other ones. I can explain it more in Zoom if you guys have more questions. And really, I'm going to go over all of these again at the beginning of the Zoom tomorrow. I just wanted you guys to watch them, get familiar with them. That way you could ask me about specific ones, like, hey, this one doesn't really make sense. So let's just move on to number 6. Number 6 says, if two planes intersect, then their intersection is a line. And this is a cool one. So two lines intersect to make a point. Two planes intersect to make a line. So when things intersect, they're always going to make the shape that is a dimension lower than it. So let's see how I can do here. All right, I'm going to try my best to draw two planes that intersect. So there's plane number 1. Let's see if I can do this. All right. Plane number 2, I'm going to draw it like that. Oh my gosh. I don't know if that makes any sense to you guys. It doesn't really make sense to me. This is hard to draw because in order for two planes to intersect, right, we have to be in 3D space. And our paper is only 2D space. So I can't really show you this, but essentially, right, where do they intersect? Okay, they intersect right here, all right? This is the line. So two planes intersect to make a line. I'll try and get two pieces of paper and show you guys in Zoom tomorrow. This is a terrible drawing. So the last one that we have is the point and line contained in plane theorem. Okay, what does that mean? It says if a point lies outside a line, then exactly one plane contains both the line and the point. So this is pretty much the same thing as this one up here, all right? This one, except instead of having two lines, we're just having a line and a point. So let's say that we have a line, all right? We're gonna draw a line. And then we have a point outside of that line, all right? This point being away from the line is what's giving us our second dimension, all right? So if we wanna draw a plane, all right, we can draw this plane right here. And that plane is gonna connect this point with that line. Again, just like above, it's not possible for there to be any other plane because just kind of for the same reason, it would have to be curved, right? If you can think of there being a plane like that. But again, planes have to be flat, so it's not really possible for it to curve around. So any plane has to hit that. Again, this is one that I could show you like with a piece of paper in Zoom. Like this would be way better for us to go over in class. My drawings are horrible. I don't know if this made any sense to you. Come with questions tomorrow. Just wanted you to watch this so you could get a little bit familiar, and so we could, since we only have 25 minutes in class, all right, so that way you can get your homework done. So come with questions. Let me know which of these don't make any sense to you at all, and we will talk about them in our Zoom meeting. Thanks, and have a great day.